All right, hello AB Calculus students. Here we're looking at 2006 question number 4. And notice they give us a chart, time, velocity. All right, so part A says to find the average acceleration. So find the average acceleration of a rocket over the time interval. Okay. So just so we can be clear, velocity's derivative is acceleration. Okay? Now, another word for acceleration, again, is the derivative of velocity. So when they say they want the average velocity, they want to know what is basically the change in velocity over time. Acceleration is the change in distance over time, but they don't want the exact acceleration, they want the estimate. Alright, so they want the estimate of acceleration at time over the time 0 to 80. Okay, so over the time 0 to 80, they want the average acceleration. Okay, now again, average acceleration just one other way of putting this, acceleration is the derivative or the rate of change of velocity. Acceleration is the rate of change of velocity, so they want average acceleration, they want average rate of change of velocity, meaning they want us to basically estimate the derivative using slope. V of 80 minus V of 0 over 80 minus 0. How much does velocity change over time? Change in velocity over time is acceleration. So basically you're finding the ordered pairs, you're finding the slope. So we're going to subtract the y's on top. The y's are down here. So we have 49 and 5. So we have 49 minus 5, and then the time on the bottom, 80 minus 0, is simply 80. If you want to simplify this, you can. That is 44 over 80. Can you simplify this? Yes, it simplifies all the way to 11 over 20, but there's no need to. They also say indicate units of measure. So we found how velocity changed. In this problem, velocity is in feet per second. So notice on the top we subtracted these numbers. We subtracted velocity on the top, feet per second, and on the bottom, 80 and 0 were time, seconds. So this is feet per second per second. Now this shouldn't come to a surprise to you because we're talking about the units of acceleration. Remember, if your position is in feet, velocity would be feet per second, and acceleration would be feet per second squared. So feet per second squared or feet per second per second. And this is the answer to part A. Again, you could have simplified it further, but we don't have a calculator. There's no reason to. Again, that's part A. All right, now let's talk about part B. I apologize for not putting a big A there like I said I was going to do. But for part B, it says, using correct units, explain the meaning of... Alright, so what does 10 to 70 V of t mean? Okay. Well, what does area underneath velocity give us? This gives us the net change in position. Now remember, there's a fancier word for net change in position. This is called displacement. However, there's even a better word. Remember we talked about this just the other day. If you have absolute values around this, this is now total distance traveled. And we said, when are these things the same thing? Well, displacement and total distance traveled are not normally equal. They're only equal if the absolute values don't have a job. And the absolute values don't have a job if velocity is positive the whole time. And if you look here, has a positive velocity the whole time. And in fact, they start off by saying rocket A has a positive velocity. So just a quick important note to make, that instead of saying this is the rocket's displacement, we can simply say it's the total distance traveled in the rocket from time 10 to 7. So again, this is the same as this, so we can say it's the total distance traveled in feet from time equals 10 to time equals 70, or over the interval 10 to 70. Now, part B asks for one more thing. They now say use a midpoint Riemann sum with 3 subintervals to estimate this. So first of all, I would like to note that we're only going from 10 to 70, not 0 to 80, but 10 to 70 and midpoint. You have to have 3 things to have a midpoint. You have 3 things, the one in the middle is the midpoint. So the midpoint's going to work like this. We're going to use these 3, followed by these 3, followed by these 3. Okay, so how far is it from 10 to 30? Again, these are rectangles, so that's a distance of 20. And then from 30 to 50, that's a distance of 20. And then 50 to 70, that's a distance of 20. Okay, now we need the midpoint. You're going to use the middle point for the heights. So the middle between 10 and 30 is 20, its height is 22. Here, middle of these two is 40, its height is 35, the height of the rectangle. And here the height is 44. We're using the middle one for the height. And our units, this is simply feet. We don't have a calculator, we don't want to type this in, everybody's good. Alright, so that's part B, that's done, and now we're going to go ahead and try part C. So if you're fast forwarding, there's part C. Alright, part C says rocket B is launched upward with an acceleration of 3 over blah 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 at time equals 0 seconds. The initial height is 0. Find the initial velocity. If and the initial velocity is 2 feet per second. Which of the 2 rockets is faster at time 80? Alright, well let's go ahead and start with rocket A. Okay? Rocket A. At time equals 80, the velocity, and sometimes we'll put a little a down here for rocket A, velocity of rocket A at 80, but we actually know it. At 80, it's at 49. So there's no work for rocket A. All the work is from rocket B. Okay, now this is where things get interesting, and there's 2 ways of doing this, but we want to know what's the acceleration at time. Wow, acceleration is not what we want. We want to know what is the velocity at time 80, and they give us the initial velocity. The initial velocity is the velocity at time 0. Well, guess what we need to add on to this? That's right, folks, it's the old net change theorem. Something to remember. The area underneath the curve gives the net change in the antiderivative. I just want you to look at this. If I went from 0 to 80 and I followed the rules, I'd say, what's the antiderivative of acceleration, which is velocity, and then I'd plug in the top and the bottom and subtract. And if I move this v of 0 to the other side, I get initial velocity plus this. Remember, initial position plus net change in position is final position. Same idea. This is initial velocity plus net change in velocity. The area underneath gives the net change in the antiderivative. The antiderivative of acceleration is velocity. So, acceleration I'm going to replace with the equation they give me. So they say acceleration is 3 over the square root of t plus 1. but I don't want to write it this way. I'm going to bring this to the top. So instead, I'm going to rewrite acceleration as 3 t plus 1 to the negative 1/2. Okay. So my velocity at time 80 is going to be my initial velocity, which we now know is 2. They told me the initial velocity is 2 plus whatever I get here. So let's talk about this antiderivative. A quick bit of u substitution says if the u is 2 plus t plus 1, the du is simply 1 dt. So is the 3 what we want? No, we'll move the 3 to the outside. So we're going to do the work off to the outside. So the 3 is to the outside. It's u to the negative 1/2. And I'm going to take the antiderivative. The 3 stays out here. I'm going to add 1 to the exponent. So add 1 to the exponent. Multiply by the reciprocal. And that gives me 6u to the 1/2. So here I get 6u to the 1/2. Except instead of to the 1/2, I'm going to call it square root. So 6u to the 1/2, the u I'm going to call a square root. And I'm going to replace the u with t plus 1. And from here, I'm going to plug in the top and the bottom and subtract. Again, we can't forget this 2 that's out in front. That 2 is just going to stay there. So I plug in an 80 minus, and then I plug in a 0. So this is 9. 81 squared root of 81 is 9. 5 times 9 is 54. 54 minus 6 times 1 is 6. So we get 2 plus 48, which equals 50. So this is rocket B. So that's rocket A, and rocket B has, again, rocket velocity of rocket B at 80 is 50. Compare the two. Which one's faster? So this one is faster at time equals 80. And that's it. That's part C. Last question. So much fun. Glad to see you. Bye.